Good day everyone, my name is Mr. Hosea Yakubu. I am here to discuss on a very interesting topic, differential calculus. Differential calculus. As we all know, when you are given a straight line, from point A to B, to find the slope of this straight line, it's as easy as picking any point on the line and get the values of x. Get the values of x where you have, this is your original x, x1, your final x, x2, to this, your original y, and your final y, to be y2. And from here, you can easily work out a very simple relationship of finding the slope m being equal to y2 minus y1 all over x2 minus x1. It can also be, referred to as slope m is equal to rise over run. Now, in finding this, it's very easy, but when you are given curves or the curve, a function that leads to a curve, it is very, very important that you know certain things. Suppose you are given this, suppose you are given something like this. Now, this is a function. Maybe we might now say y being equal to x squared. Now, if we want to find the slope of a particular point, let's say x, we cannot just find it straight like we did on the previous one. For this, we have to go to any point on the curve, let's say here, and pick another point. If we call this point A and this other one point B, then we rule a line. Now, at this point, we call this point second. Now, we can also rule this at this point to have our x. Let's say if we call this one x, we can call this x plus change in x. That is increase in x. Now, and for y, if we have this, we might call this other place, we might call this, instead of calling this y, we can call this place f of x, which is the same thing as y. Now the coordinates of this point A will be x, comma, f of x, like this. While the coordinates for this other point B will be, now this, instead of x, it will no longer be x, this place will not be y. It will now give us x plus change in x, then comma, this time around, f of x plus change in x, like this. So these are the coordinates of point B and the coordinates of point A. Now, if we're able to do that, we can now relate it to our simple formula for for m, for the slope m being equal to y2 minus y1 all over x2 minus x1. In this case, it implies that m will be equal to our y2 is f of x plus change in x. Then we now say minus our y1 is f of x all over x2 now will give us x plus change in x minus x1 will now be x. So if we work out this, that will give us m will be equal to f of x plus change in x minus f of x all over. Now this will strike out this, you are left to change in x. Now this is the slope of the secant. This is the slope of this secant. But if we want to now proceed, to get our derivative. Now we are almost getting our derivative as at this point. Looking at what we have, there's a very simple relationship that we need to. You see, from this point now, this is a fixed point. We've gotten our gradient. But this gradient will not give us the exact gradient, because there are certain things, like this curve here, there are certain things that are still left. It might be close to the value, but it will not give us an exact value. So for us to be accurate, we can see situations where this point will be reducing, coming, you are bringing it down, 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 down. So now, and that leads us to, you are limiting the values of point B to A. So if we are going to do that, it means that for us to do that, we need to take the limit of f of x plus change in x minus f of x over change in x. Now as x, change in x, as this is coming down, you discover that change in x is also reducing. Now as change in x tends to 0, coming back to 0. So if we're able to do that, we taking the limits of this is leading us to a very simple case called the derivative. We now say therefore the derivative denoted by f prime of x is equal to the limit of, sorry, let me clean this. The limit of f of x plus change in x minus f of x comma change in x as change in x tends to 0. So this simple relationship is what is called derivative. The derivative of f of x. If, as we are saying it might not really make sense until we are able to apply it. In applying it, let's see, suppose you are given something like this. Y being equal to 3x squared plus 5. And they say, okay, find the derivative. Find the derivative of the function with respect to x, WRT with respect to x. Now what do we need to do? It's as easy as, we now say, okay, from here now, we now say instead of y now, let f of x be equal to 3x squared plus 5. And with that will now be, it means that for us to be able to find our f of x plus change in x, we now say f of x plus change in x will be equal to 3 into x plus change in x all squared plus 5. Now if we're able to do that, we'll now notice that you can expand this. So f of x plus change in x will be equal to 3 into, when we expand, we now have x squared plus 2x change in x, then plus change in x all squared plus 5. So if we expand this, we'll be left with f of x plus change in x will be equal to 3x squared minus 6x change in x plus 3 into 3 change in x all squared, then plus 5. So we now say, okay, from what we have, f of x plus change in x minus f of x will be equal to, now that will give us 3x squared minus 6x change in x plus 3 change in x all squared plus 5 minus, like this, minus our f of x is something like this, 3x squared plus 5, like this. So if we expand this bracket, we now have f of x plus change in x minus f of x will be equal to 3x squared minus 6x change in x plus 3 change in x all squared plus 5, then minus 3x squared minus 5. Expanding this bracket. Now you will notice that this will clear this. Similarly, this will clear this. So we will now see that our f of x plus change in x minus f of x will be equal to minus 6x, sorry, it's plus, then 6x change in x, then plus 3 change in x all squared. Now, we know that from our derivative, the derivative is the limit of f of x plus change in x minus f of x all over change in x. So we now divide, it means that we will divide all through by change in x here. That will now give us 6x change in x plus 3 change in x all squared over change in x. Now if we're able to do that, this will be the same thing as change in x into 6x, then plus 3 change in x, then over change in x. Now this will clear this. We'll be left with 6x plus 3 change in x. Now the limit of f of x plus change in x minus f of x over change in x as change in x tends to 0 will be the same thing as we're taking the limits of this. We now say it implies that it will be equal to lim of 6x plus 3 change in x as change in x tends to 0. Now when it's tending to 0, our result will now end up being 6x. That is our solution for this. It's not very hard. Thank you. There are instances where you don't have to follow that long process. I will give you an alternative method to be able to work out your ways. Suppose you are given y being equal to x squared plus 5x. Now I want to use the first principle to work out this. Maybe they say, okay, fine. They will say if y is equal to this, find changing y over changing x, which is the same thing with f of x, sorry, f prime of x. It's the same thing. They're finding a derivative with respect to x. Now, if we're going to do that, we can take another method now. You can now say, okay, let y being equal to x squared plus 5x be equation 1. You name it. Then you now say, okay, for every change that affects the independent variable will also affect the dependent variable. That will now give you y plus change in y will be equal to x plus change in x all squared plus 5 into x plus change in x. So if we have that now, you can now simplify. I'll have y plus change in y being equal to, so this other one will now be x squared plus 2x changing x plus changing x all squared. Like this, then plus, open this, you now have 5x plus 5 changing x. Now, if we're able to have that, let me just open up, still simplify further. I will end up having y plus changing y will be equal to x squared plus 2x changing x plus changing x all squared plus 5x plus 5 changing x. You call it equation 2. If you're able to simplify to this point, you call it equation 2. Now, you can now say subtracting equation 1 from 2. Subtract equation 1 from 2, which means the original from the final to know our value of change. If we are doing that, this side I will end up having y plus changing y minus y. On the other side, I will end up having x squared plus 2x changing x plus changing x all squared plus 5x plus 5 changing x. Is that minus, then minus x squared plus 5x. So when we expand this, this will clear this automatically. I will be left with changing y on the left hand side being equal to, so we now have x squared plus 2x changing x plus changing x all squared plus 5x plus 5 changing x minus x squared plus, minus 5x. So from here now, this will clear this, a number and its additive inverse, then this will clear this, a number and its additive inverse. We'll be left with, coming down to this, we'll be left with changing y being equal to 2x changing x plus changing x all squared, then plus 5 changing x. Now, if we have that now, we are looking for dy over dx. Then as at this point, you now say, okay, divide all through by changing x. That will give you changing y over changing x will be equal to 2x changing x over changing x plus changing x all squared over changing x, then plus 5 changing x over changing x. Now this will clear this, you are left with changing x, this will clear this. You are left with changing y over changing x will be equal to 2x now plus changing x plus 5. Then we'll now take the limit. We'll now say as changing x tends to 0, we'll end up having changing y over changing x will be equal to 2x plus 5. And this is the derivative of the function we were given. Thank you. There are instances where the function you are given might be a fraction, and they want you to find the derivative. If y is equal to 1 over x squared, is that find changing y over changing x. Now from this, don't be scared. With the foundation we already have, anything you are given, you can apply the first principle and you will still get it. Now look at this. Suppose you are given something like this. What do you need to do? I will now say solution. Let my y being equal to 1 over x squared be equation 1. Then from here now, I will now say, okay, the increment in x will also affect increment in y. Y plus changing y will be equal to 1 over x plus changing x all squared. So if I'm able to say, if I'm simplifying this now, that will give me y plus changing y being equal to 1 over x squared plus plus 2x changing x plus changing x changing x all squared. Now, from here now, what you now need to do, since you cannot simplify further, you can call this equation 2. Then in subtracting equation 1 from 2, see what happens. This will be subtracted from this. Then for this other one, we now have changing y will be equal to 1 over x squared plus 2x changing x plus changing x all squared minus 1 over x squared. Like this. Then as at this point, you know how to simplify your algebraic fractions. We'll just do that. That will give us changing y will be equal to, now our LCM is x squared into x squared plus 2x changing x plus changing x all squared, like this. Now, this into the whole of this, we're left with x squared times 1, this will now be x squared. Then x squared into this, we're left with this times 1, we have minus x squared plus 2x changing x and plus changing x all squared, like this. So we expand the numerator. If we do that, see what we have. We'll end up having changing y will be equal to x squared minus x squared minus 2x changing x, then minus changing x all squared, all over x squared into x squared plus 2x changing x plus changing x all squared, like this. So if we are able to do that, you see this will clear this. A number and its additive inverse. We have changing y will be equal to minus 2x changing x minus changing x all squared all over. Now we can expand the denominator. If we are doing that, we'll end up having x raised to the power of 4, x to the power of 4 plus 2x to the power of 3 changing x, then plus x squared changing x all squared. Now if we're able to do that, it's very simple. The next thing we need to do is to divide all through by changing x. If we are doing that, we now have changing y over changing x will be equal to, so we now have minus 2x changing x minus changing x all squared all over x raised to the power of 4 plus 2x cubed changing x plus x squared changing x all squared. Then we now say divide by changing x. Now when we do that, changing y over changing x will be equal to minus 2x changing x. We can factor out, sorry, let me even factor out. That will now give us changing x into minus 2x, then minus changing x, like this, all over. So we now have x raised to the power of 4, x to the power of 4 plus 2x to the power of 3, changing x, plus x squared, changing x all squared, times 1 over changing x. So this changing x will clear this changing x. When you cancel it, see what you have. Changing y over changing x will be equal to, you have minus 2x minus changing x over x raised to the power of 4 plus 2x to the power of 3 changing x plus x squared changing x all squared. Then as changing x tends to 0, see what happens. We'll end up having changing y over changing x will be equal to, so this place will be 0, we are left with minus 2x all over. Now this place will be 0, this will be 0, we are left with x raised to the power of. You will discover that this x will reduce this. Now we're left with x to the power of 3. So that will give us x dy over dx will be equal to minus 2 over x cubed. Yes, but you can still write it in another format. We can write it as this. Changing y over changing x is same as minus 2x raised to the power of minus 3. Thank you. Okay, from what we've done, you will notice that if y is equal to x squared, then changing y over changing x will be equal to 2x. Similarly, if y is equal to 3x squared, then changing y over changing x will be equal to 6x. If y is equal to x cubed, then changing y over changing x will be equal to 3x squared. Now from this, we can have a very simple deduction that will lead us into what we call the general power rule. Now, it means if y is equal to ax raised to the power of n, then changing y over changing x will be equal to, now, n, a, x, n raised to the power of minus 1. Now the power will be multiplied by the coefficient and the power will reduce by 1. This is called the power rule. Thank you. Now, from the general power rule, we said if y is equal to ax raised to the power of n, where a is the coefficient of x raised to the power of n. Now, we said then dy over dx will be equal to na x raised to the power of n minus 1. Now, if you want to apply it, the application is very simple. So, it means if you are given y being equal to 3x squared, and we're asked to find dy over dx. Very simple. In applying this, you now say, okay, therefore, dy over dx will be equal to, now, 2 will be multiplied by the coefficient. That will now be 2 times 3 times x raised to the power of 2 minus 1. So if we do that, we end up having dy over dx will be equal to 6, this times this, then x 2 raised to the power of 1, sorry, x raised to the power of 2 minus 1 will be x. So this will be our solution for now. Implication, if you're also given another example of a function y being equal to 2x cubed plus 3x squared minus 4x plus 2. Now, and we're asked to differentiate this with respect to x, or find dy over dx, or find the gradient of this. It's as easy as saying, okay, we now say our dy over dx, this will now be 3 times 2 x raised to the power of 3 minus 1 plus this 2 times 3 x raised to the power of 2 minus 1, then minus 4 times 1 x raised to the power of 1 minus 1, then plus, here we now have 2 raised to the power of x, 0 times 2 dot x raised to the power of 0 minus 1. Now, if we're able to do that, because for every constant term, there is a coefficient, sorry, there's x raised to the power of 0 attached to it. Now, if we are able to do that, we'll end up having dy over dx will be equal to, this place will now give us 6x squared. Now, while this place will now be plus 6x, now this will give us minus 4. This will be 0, so we are cleared of that. This will be our solution for now.